last one, more of this kind of messy looking notation. If b is a linear function and b of 1 equals 4 and b of t plus 4 minus b of t equals 3, we want to find an equation. Okay, so once again, we're being given a point. We'll have to do a little more work this time because our point is not the y-intercept. We're also given partial slope information here. We have to piece it together a little bit. So whenever I see b of t plus 4, I'm thinking, okay, that's a y value for function b. B of t is another y value. So if I take the difference between two y values and get 3, that means that my rise is 3. With function notation, you can always see what your x values, or in this case your t values, are. So I'm starting at t and I'm stopping at t plus 4. So we should be able to see there that t plus 4 minus t is always going to be 4. So this is basically just saying it's a linear function. No matter what your starting value is, if you choose a fixed run, you will get a fixed rise. It doesn't matter if you start at the y-axis or start way off somewhere in one of the quadrants. You always should have a fixed rise to go with a fixed run. So for us, our run is 4. The difference between our input values is 4, which means our slope is 3/4. Okay, so this time, again, you can absolutely use point slope form. I have no problems with it, but you don't have to. If you prefer to always use slope intercept form, I tend to use it more often. You can find your b value without using point slope form. So let's just start with the information we have. So far, we know that b of t is equal to 3/4 t plus mystery unknown value of our y-coordinate of our y-intercept. Since I was apparently rude to us and I chose b as the name of my function, I'm just going to call this a big B. It is important that it's not the same variable. If b is your function name, it cannot also be the name of your y-intercept. But a little b and a big B are different variables, so that would be completely acceptable. Another thing you could do, notation that's really common to see in calculus and in some of the sciences, is to use a subscript. Call this little b sub 0 to specify that that is a certain value of function b. In fact, it's the initial value. Okay, so not required, but perfectly legal. To use slope intercept form to find the y-coordinate of your y-intercept, what you would do is take as much information as you've got, which is really just the slope right now, and then you can plug in a single point, any point. What we know is that a point on the graph should make the equation a true statement. It should be a solution to the equation. So by plugging in a known point, I know that the statement I ended up with is a valid one, and I can use it to solve for b. If I just arbitrarily pick an input and an output value and I don't know that it's a point on the graph, I can't assume that this equality actually holds, but that's not what happened. I definitely chose a point that I know is on the graph. Okay, so it looks like I just need to subtract 3/4 from both sides. Notice that 4 is 16/4, which means we're going to get 13/4 equal to b. Excuse me, I almost made it without coughing in your ear. So our equation is b of t, and let me not confuse this, this is a big B, is equal to 3/4 t plus 13/4. Okay, long one, but that was all the examples for function notation to get information for linear functions. Thanks for watching.